All right, I do want to go through one really complicated example of using u substitution with a definite integral. And so in this problem we have square root the integral from 1 to 5 of x over the square root of 2x minus 1 dx. Now this problem is done in the book, and you can refer to that and look at the different way that they solve it. I'm going to solve it the way that it would appear most naturally to me, even though their solution may be more elegant. You can learn from that, but it's not something that I would think of off the top of my head. Alright, so we have this composition here. We have 2x minus 1 under the radical, and the derivative of 2x minus 1 is 2. It's not exactly going to get rid of the x, so I'm going to have to try to swap out or to write x in terms of u and then swap out later. So let's see how that goes. We're going to start out with the inside function of the function composition as my u. And so u is equal to 2x minus 1. And du is equal to 2 dx. But I don't have a 2 dx there, so I'm going to solve that for dx. And so I get 1/2 du is equal to dx. And of course I can swap out 2x minus 1 is equal to u. That's still going to leave me with an x in the numerator, and I still have my limits in terms of x instead of u. So recall that u is really a function of x. And if I want to find out what u is when x is 5, I ask what is u of 5? And when x is 5, I get 9 for u. And if I want to find out what u is when x is 1, then I ask u of 1 is equal to what? U of 1 would be equal to 1. So at this point I'm also able to swap out my limits of integration, and I have everything except that x in the numerator. And so I need to try to use my definition of u in terms of x to write x in terms of u. And we've done this exact same example before. And starting with u equals 2x minus 1, if I add 1 to both sides and then divide by 2, I get that u plus 1 over 2 is equal to x. And I'm ready to put all the pieces together and rewrite my integral. Now first of all, I have a 1/2 from the 1/2 du, and I also have a 1/2 from the x. Remember now that my numerator is really 1/2 of u plus 1. And so I have a half in the numerator, and I also have a half from the 1/2 du that I swapped out for dx. So really I should have 1/4 on the outside. And you have to watch that very carefully. Then I'm ready to put in my new limits of integration, which are 1 and 9. My numerator is u plus 1. My denominator is u to the 1/2. And my variable of integration is u, or du there. Alright, so what I can do with this at this point is to split this up into two terms. And when I do that, I get u over u to the 1/2, and that u is really u to the 2/2 over u to the 1/2, which is u to the 1/2. And then 1 over u to the 1/2 is really u to the negative 1/2. And so now I've completed that, and I'm ready to perform the integration. The antiderivative of u to the 1/2 is 2/3 u to the 3/2. The antiderivative of u to the negative 1/2 is 2 u to the 1/2. And that's from 1 to 9. And if I write that all out, okay, so when I substitute in, remember I'm going to evaluate the antiderivative, evaluate at the upper limit, subtract the antiderivative evaluated at the upper limit minus the antiderivative evaluated at the lower limit. And when I plug that all in, I get 1/4 times this big quantity, 2/3 9 to the 3/2 plus 2 times 9 to the 1/2 minus 2/3 1 to the 3/2 plus 2 1 to the 1/2. Now in case you don't remember how to evaluate 9 to the 3/2, that's power over root. You can do the root first, so 9 square root of 9 is 3 to the 3rd is 27. And 2/3 of 27 is 18. Square root of 9 is 3 times 2 is 6. Then I'm going to subtract from that 2/3 plus 2. And I'm running out of time, but that gives 16 over 3.